Hey there, welcome back to part two. Now, in epidemiologic studies, estimates of exposure and dose have been used to quantify the relationship between an environmental factor and the health status of a population. How much one has been exposed is also an important consideration. Does one have an increased risk of cancer after only one X-ray, or does it require multiple doses? So figure 9.3 illustrates how the exposure increases, aka increasing the dose, potentially in this particular case, looking at the risk of asbestos exposure and the risk of lung cancer. So if the exposure level is low, the relative risk is quite low. But then as that exposure increases over time, so does that risk, the relative risk of developing lung cancer. Sometimes a proxy measure is used. So a proxy measure of exposure is used. For example, traffic flow per hour in a particular place or the gas consumption per year is used as an indicator of air pollution exposure. Now looking at biological monitoring, if the environmental factor under study is a chemical, the exposure level and dose can sometimes be estimated by measuring the concentration in body fluids or tissues. This is called biological monitoring. Blood and urine are the most commonly used biological monitoring tools or specimens. Other biological tissue can also be used, such as hair, looking at methylmercury from fish, nail clippings, giving an idea about arsenic exposure, and feces to look at metal exposure. So it is interesting, if you remember back from the pandemic period, they talk about looking at wastewater to get an idea about potential presence of COVID within the population. Monkeypox, which was that next crazy thing that was occurring in 2022. Not that it hasn't gone away. You'll hear it pop up here and there now and again, but they were exploring monkeypox and trying to get an idea about the potential number of cases based upon its presence in wastewater. So if you're interested in doing something with biological data, obviously we would need to be able to partner with someone who has expertise in the collecting and analyzing of this type of data. Same type of thing goes for something like this. If you're interested in, epidemiology of jumper's knee, talked about this last week. Well, I don't have experience in doing epigenetic testing. I have experience in the sports epi side of things. This is where we would need to potentially partner with somebody that has that expertise. One of the benefits of working in a large institution, potentially. Now, looking at population dose, in epidemiologic studies of cancer caused by environmental or occupational factors, another way of presenting group dose is sometimes used, these being the dose commitment or population dose. It's calculated as the sum of individual doses. It's based on a fundamental assumption that there is no threshold individual dose below which the cancer risk is zero, and the cancer risk increases linearly with dose. So the dose-effect relationships for many environmental factors, effects range from subtle physiological or biochemical changes to severe illness or death. Usually the higher the dose, the more severe or intense the effect. This relationship between dose and severity of effect in the individual is called the dose-effect relationship. It's illustrated here in this particular figure 9.5, and in this figure here, we're seeing an increase in carboxyhemoglobin in the blood and how that leads to either minor symptoms at first, like slight headache or headache and dizziness, progressing all the way up to death. This relationship provides valuable information for the planning of epidemiologic studies. Some effects may be easier to measure than others, and some may be of particular significance for public health. Measurements of changes in biomarkers may be used to study early subtle effects as well as the exposure. Now looking at dose-response relationships, response is defined in epidemiology as the proportion of an exposed group that develops a specific effect. The shape of the relationship looks like an S. At low doses, almost nobody suffers the effect. At high levels, everyone does. So here is an example. When we think about things when it comes to traffic injuries, at low speeds, the probability of death is much lower, but at much higher speeds, it increases substantially. Other types of situations where there is this S-related dose-response curve include those seen in workplace injuries, violent events, and suicides. So as I said before, with a traffic crash-related injury, there's that dose-response relationship. Understanding that speed is an issue, speed reduction, measures in place by decreasing speed in certain areas that are riskier, and also requiring the use of seatbelts. So this particular slide here shows the relationship between driving speed, seatbelt, and the use, seatbelt use and the frequency of injury in drivers involved in collisions, and how shifts could lead to decreases over time. Workplace injuries. So examples could be exploring chemical exposure in agricultural workers. A small exposure to chemicals may have that kind of minor effect, but a major exposure could lead to a severe response. Violence is another public health problem that's been highlighted through epidemiologic analyses. In some countries, homicides are a major cause of death among young males, can be even worse in some low and middle income countries. And in suicide, another important cause of death, the environmental factors causing suicidal intent are primarily social or economic, but completed suicides are also dependent on access to suicidal methods, which can be seen as an environmental factor. All right, so that wraps up just some concepts from this chapter. For this week, you're going to be proposing a research study, like I said before, in the first screencast. And you want to include the population, the setting, the length of the study, and the exposures. So my example would be like a prospective cohort study. My population and setting would be male migrant vineyard workers. The setting would be vineyards in Washington and Yamhill counties in Oregon. The length of the study would be 1 season from February through harvest. Collecting measures associated with the spine, so listing some different things there to assess strength. And exposures would be the daily work exposures, collecting that information on the different jobs they do during the different times of the year. For your homework, you're going to provide one example of a prospective, retrospective, and case control study related to environmental or occupational epidemiology.